Hi everybody and welcome to a new episode of Diagnosedan. Today we're working on a 2010 Skoda Jetty and this car was towed into the shop. One of my other technicians took a first quick look and he wrote, "The gearbox is no longer responding, the gear indicator is flashing on the dash and there's an underhood fuse, a fuse in the underhood fuse box, F2, a 30 amp fuse that keeps blowing, and this fuse is for the transmission control module." Now this is a DSG gearbox that is used throughout the Volkswagen group. So Volkswagen, Audi, Seat, Skoda, a very common gearbox. So I thought this might be interesting. Anyway, this is where we are, so let's diagnose this together. Now before we continue diagnosing our DSG transmission, I want to do a little sidestep. Now in our shop, we've been using Mechatronic battery testers for years, and we recently upgraded to the CPX 900 series to replace some of our older models. Now as I was talking to a Mechatronics technician, he told me something very interesting. He told me that European roadside assistance statistics tell us that over 50% of all breakdowns are battery or charging system related. I mean, that's 50% of breakdowns that could have been easily prevented. Now, if we can prevent 50% of all breakdowns just by doing a simple test, that's exactly what we're going to do. So at our shop, we try to test as many vehicles as possible. Now imagine we diagnose and fix this transmission, and in a week's time, this car breaks down by the side of the road because of a simple battery-related problem. How would it make us look? So that's definitely something we want to prevent from happening. Most battery testers will just give you cold cranking amps. Now if you got good cranking amps, this will pretty much make sure the car will start. Now in the old days, you would start your car and drive it for a while, giving the battery time to recover and recharge. A modern car has got start-stop systems and a lot more electronics that demand energy from the battery, maybe even when the engine is not running. So just testing for cold cranking amps will tell you if the car is going to start, but it won't tell you if it's going to start again and again and again, and all while supplying a lot of energy to all these electrical systems. So just testing for cold cranking amps isn't sufficient anymore. So that's why you'll need a tester that tests for reserve capacity. And that's exactly why we upgraded to the CPX 900. Now, unlike my other testers, this battery tester has got a heating element built into it that will load the battery for a while and then calculate the reserve capacity. Now, you might think I can do exactly the same thing by turning on my headlights, creating a load, and then watch how long it takes before the headlights get dim. And you're partially right. But there are a lot of variables like temperature. Temperature has got a huge influence on the performance of your battery. If you're doing this test inside a heated workshop or outside on a sunny day, you might think your battery is good. But then it starts freezing overnight and it might prevent your car from starting the next morning. Now this tester has got a lot of sensors built into it, like a temperature sensor. It will take all these things into account to give you a solid and professional result. Now let's start out by connecting the battery tester. There we go. And turning it on. And then all we need to do is just get the information from the battery and enter it into the tester. So we're testing inside the vehicle. It's a flooded battery. The units are EN. It's rated at 480 amps. Okay, it's a 60 amp hour battery. And let's start testing. Then it wants a reading of the temperature. And there we go. Now this machine is connected to the Wi-Fi, so we can either print or email the results. So this battery failed the battery test, and because it failed the cranking test, the tester didn't even bother to test the reserve capacity. So this battery needs to be replaced. Now, before we do that, let's take the new replacement battery and bench test it before we put it into the car. Let's change the location to outside the vehicle. It's a flooded battery, EN. It's 540 amps, 60 amp hour. And let's start the test again. Let's capture the temperature, and there we go. And the heater comes on, so now the tester starts testing the reserve capacity. And it's done. Let's check the results. Good battery. And battery meets or exceeds required standards. And the battery has got sufficient reserve capacity to provide power for the electronic systems in the vehicle. Now that was some information on how to properly check a modern car's battery and why we do it, of course. Now, I don't know if there are any other brands out there that test for reserve capacity. We've been using Mechatronics forever. We like their products, and I haven't really looked into any other brands. Now, I changed this battery, and I guess the moral of the story is a lot of cars break down because of battery-related problems. So testing is important, okay? Now, before we get too sidetracked, I want to go back to our transmission problem. I want to confirm the customer complaint, so I'm going to start the car, go through the gears, and see if the car moves. So let's start the car, and let's go through the gears, reverse, neutral, drive, and let's rev the engine up. And as you can see, no response whatsoever. The car is not moving, not in any gear, not in drive, not in reverse. So I guess that's customer complaint confirmed. Now my colleague already did some work for us, and he told me that there is a fuse in this underhood fuse box F2. It's a 30 amp fuse, and it's for the transmission control unit, and it keeps blowing. So let's confirm that. Let's hook up our test light to battery negative. And let me see. F1 to, yeah. It's this 30 amp fuse. And if it's good, it should have power on both sides, right? So it's got power on this side and no power on that side. And let me see. Oh yeah, that's a blown fuse, so that's confirmed. Now I want to confirm we have still got an active short to ground. So I'm going to replace that fuse, and if we do, that fuse is going to blow. Oh yeah. Our short circuit is still there, and I looked into a wiring diagram, and it looks that 30 amp fuse only feeds the transmission control module, which is mounted within the transmission. In the next step, I want to remove the connector from the transmission and see if the short is still there. If it is, the short must be in front of the transmission. If it isn't, the short is within the transmission itself. In order to get better access to that connector, we need to remove the air filter housing. Now, I don't know how good you guys will be able to see this because there are hoses and wires in the way, but that connector is right there. And you need to pull up on that plastic tab in order to remove it. And then we should be able to bring that connector up. I've got the connector removed from the gearbox, so let's replace that fuse again for a new one. And it looks like this time, with the connector removed, the fuse doesn't blow. I inspected the gearbox side of the connector, but I could see nothing out of the ordinary. So to get any further, we really need to open up this transmission. So in the next step, I want to remove the mechatronics, and this is the part that holds the actuators and the electronics. I want to remove that from the side of the transmission, put it on the workbench, and see if we can find the cause for a short to ground. And hopefully, along the way, I can give you guys some insight on how this special transmission operates. DSG stands for Direct Shalt Getriebe, or in English, Direct Shift Gearbox. Volkswagen uses two mainstream versions, a dry clutch version and one that uses a wet clutch. Today we are working on a dry clutch DSG. Although we've got an automatic gear shift lever inside the car, this 7-speed DSG is basically a 4-speed manual and a 3-speed manual transmission combined together in one housing. If you want to integrate two gearboxes in one housing, you basically need two of everything. So inside this gearbox, we can find two clutches, two input shafts, and two gear sets. A set of gears for a 4-speed and a set of gears for a 3-speed manual transmission. The gear sets inside this DSG are basically similar to those of a manual transmission. These are the shift forks which are being used to change gears. But instead of you manually changing gears with the shift lever inside the car, in this box, the Mechatronics does the shifting for you. Here in the corner, we can just see the flywheel with the clutch packs. You can clearly see there are two clutch levers, one on the inside and one on the outside. There's a clutch for the even gears and a clutch for the uneven gears. But again, instead of manually controlling the clutch with a clutch paddle, the Mechatronics controls the clutch for you. What a DSG gearbox does is when you're driving in a gear, let's say first gear, the other gearbox has already selected second gear for you. So when the time comes to change gears, The transmission releases one clutch and engages the other, resulting in a seamless shift in milliseconds without any shifting delays, resulting in a very smooth ride. That's why this gearbox is called a direct shift gearbox. This is basically a brilliant gearbox, that is, if everything is working as it's supposed to, of course. When we take a closer look at the mechatronics, we can clearly see the 4 pistons that interlock with the shifting forks that are being used to change gears. In the middle, we've got the electronic control module, and when we take a look at the side, we can clearly see 2 pistons that are being used to control both clutches. This mechatronic unit uses hydraulic pressure for shifting and to control both clutches. Now this system is a totally sealed system, totally separated from the gearbox oil. This means all the hydraulic fluid should still be in here. It shouldn't leak on the inside and it shouldn't leak on the outside either. Now in the next step, I want to drain this unit from its fluid to see how much fluid comes out of there, to make sure none of the hydraulic fluid has leaked into the gearbox oil. Now the oil you saw coming out when I disassembled this unit was actually the gearbox oil itself. We drained this unit and we drained exactly 1 liter, which is perfect because this unit holds a little over a liter. Now I just drained it and there will be some oil left in there, and we will find that once we take it apart. Now, as far as our diagnosis is concerned, we've learned 2 very important things. The first thing we have learned is that the mechatronics unit hasn't been leaking hydraulic oil into the gearbox, contaminating the gearbox oil and potentially damaging the gearbox itself. Another thing we've learned is that there was sufficient oil inside this unit. Inside this unit, there's an electric motor driving a mechanical pump to provide the hydraulic pressure. Now, if there isn't enough fluid, the pump could overheat and potentially short out our electric motor. Now, I'm not saying our electric motor isn't shorted out, but I'm saying it's not because there wasn't enough oil inside. In order to find the short, I need to take this unit a little bit further apart. So in the next step, I'm going to do that. And after that, I'm going to talk you guys through the results. Now before I take this unit any further apart, I want to take you through the components. This is our electric pump motor, and on top of that is our hydraulic pump. On the sides, you can see the solenoids that control both clutches and the gear shifters in the back. This is an accumulator that makes sure there is constant pressure in the hydraulic system. This is all controlled by the control unit that sits in the back. Now the cover is basically just an oil pan and acts as an oil reservoir. I totally took the unit apart and I found that the control unit, the back of the circuit board, this is the control unit and this is the back of the circuit board. This is a speed sensor, by the way. I found that the back of the circuit board over here has been totally burned. Now I don't know why the circuit board overloaded. So in the next step, I want to do a visual inspection and take some measurements. You can clearly see where the circuit board burned over here, and I wish you guys could smell this because it really smells like burnt plastic. Now, if you lay it on top of the unit, how it's set before, you can even see that there are burn marks on the housing itself. Let's take a look at that little mechanical pump. And it's not hard to spin, it spins freely. And when we take it apart, there seems to be no signs of wear or tear. No metal shavings, nothing. Everything seems to be fine. This is the block that holds the solenoids, and as you can see, there's a little filter in there. And I can see nothing wrong with it. No metal shavings, no nothing. But maybe one of the solenoids shorted out, and that caused the circuit board to short out. So in the next step, I want to do a quick resistance check. Let's start out with the first solenoid. And that's about 5.8 ohm. The second one, 5.8. Next one, 5.7, 5.8. This one is about 5.8. Next one is 5.8. Again, about, hold on. Yeah, 5.9, 5.8. And the final one, also about 6 ohms. So they're all about the same. Apart from the solenoids, the only other electric part that could potentially overload the circuit board is the electric motor. When we take a closer look at this electric motor, we can see there has been some heat development, but nothing extraordinary. Now I would love to make this motor spin, but in order to see if it works, I would need a 3-phase power supply, since this is a little 3-phase motor. Now I don't have a 3-phase power supply, but there is another neat trick we can do to see if this motor is any good. Now if this motor is any good, we should also be able to use it as a generator. So when we hook up a multimeter and spin the motor, we should see a voltage there. And let's try the other phase. And the last phase. And it looks as if this motor is still good. Now most stuff inside the Mechatronics are mechanical, like our little hydraulic pump. And this, by the way, is an accumulator. And an accumulator is basically a pressurized canister filled with gas and a membrane that evens out or smoothens out pressure pulses in the hydraulic system. But apart from the mechanical stuff, the only electrical components are the solenoids and the electric motor. But besides the burnt circuit board, I can find nothing wrong with this Mechatronics electrically or mechanically. Since I couldn't find the cause for the burnt circuit board, I decided to check for TSBs. And there is actually a TSB for exactly this problem. And that TSB states that in the past, Volkswagen used an oil that contained too much sulfur, and that could over time short circuit the module inside the Mechatronics. Now, since I have no history on this car, I don't know if the oil was ever changed for an upgraded better version, but depending on the looks of the circuit board, I guess they never did. Now, since the control module is one of the most expensive parts in this Mechatronics, and since there are a lot of other parts that could easily fail, I called up the customer and I advised him to go for a remanufactured unit. He agreed, so I called my buddy Sam at ATR Transmissions and he hooked me up with this lovely remanufactured unit, of course filled with the right oil to prevent this problem from happening again in the future. Now all I need to do is install this unit onto the gearbox, which should be pretty straightforward. There's just one little procedure you need to be aware of, and I will show you that in a minute. Now, if you get a new unit from Volkswagen, it comes pre-programmed. If you're going to install a used unit, make sure you program the unit onto the car. Now, I decided to go for a remanufactured unit. Now, the guys at ATR Transmissions already updated this unit with the latest software for this VIN number. So this unit should be plug and play. Before you install the new unit, you have to make sure the gearbox is in neutral. Take the shift forks and make sure they are in the center position. You can move them to the right, to the middle, and to the left. Make sure all the shift forks are in the center position. Then make sure that all 4 pistons extend exactly 25 millimeters to line up with the shift forks. When you replace the Mechatronics, make sure you do a DSG Mechatronic basic calibration. The basic setting may be performed only after the following repairs: software adaptation, replacement of the Mechatronic, replacement of the clutch, or a relevant event memory entry. Now again, make sure you've got a good battery installed or a battery maintainer hooked up. Now when I hit continue, the gearbox will go through the calibration procedure. We have replaced the fuse, replaced the Mechatronics, relearned the Mechatronics, and I've topped up the gearbox oil again. But did we actually fix the car? Will it move? Well, we're about to find out. Reverse. Oh yeah. And drive. And at least it's moving again. I test drove the car and it shifts like a new one. Now, an important lesson we can learn from this video is to check your TSBs. How could we have known that the oil was causing our problems? I guess we couldn't have known without checking the TSBs. Now, I hope you liked this video, and if you did, and if you want to learn more, please subscribe to my channel. When you hit the little bell, you will get a notification each time I post a new video. And remember, Diagnosedan, fixed it again. See you next time, guys. Hi everybody, and welcome back to a new episode of Diagnosedan. Modern cars have got stop-stop. Now, unlike my other brother, now in modern cars, you've got stop-stop.